Okay, so let's wait few minutes, then we'll discuss. Okay. Okay, so let's start gradually. Then let me just share my screen. Just a second, I'm just logging out and I'll rejoin. Okay, so I will join in 1 minute. Okay, let me just yeah. Let's start. Okay, so basically today, so Sikha today sent me 2 questions. So first we'll discuss those questions and then we'll solve some previous year questions from conductance electrochemistry chapter. If you have also any doubts, then you can also send me your doubts, then we'll discuss. Okay, so the first question is, I'll just write down the question first, then solve. So this is from quantum chemistry. Okay, so the wave function of a 1D simple harmonic oscillator between x equal to plus infinity to x equal to minus infinity is given by, so psi x is given, which is n 2x square minus 1 exponential minus x square by 2. Then we have to find out the value n here. So here n is actually the normalization constant. So we have to find out the value of n. So for 1D one-dimensional simple harmonic oscillator between x equal to plus infinity to x equal to minus infinity, the wave function is given and we have to find out the normalization constant. So here some basic integration is given, the minus infinity to plus infinity, then x to the power 2n exponential minus x squared dx is equal to 1 3 5 2n minus 1 divided by 2 to the power n root over of pi. So this integration is given. Okay, so we have to use this integration and then find out the value of normalization constant. Okay, so basically the condition for normalization is, so we know that if for any wave function psi, let's say in general any wave function, so psi has to be normalized, right, between the given range. That means mod of psi square, let's say it is one dimensional wave function, that means psi is only a function of x, so mod of psi square dx integration the range minus, let's say, a to plus a has to be equal to 1, right? That means here in this case it is minus infinity to plus infinity. Mod of psi square means, so basically psi times psi star, mod of psi square means dx has to be equal to 1, right? So here psi, the psi that is mentioned, so it is a real function, so psi and psi star is equal. That means minus infinity to infinity n square, it will be n square because psi and psi star is equal, like identical. So n square times 2x square minus 1 square x square divided by 2 whole square dx is equal to 1, right? So in, okay, sorry, so n square minus infinity to infinity 2x square minus 1 square, then 2 will cancel, exponential minus x square dx equal to 1, right? So now, so to find the value of n, so we have to first integrate this part, right? So basically we have to do just minus infinity to infinity 2x square minus 1 square exponential minus x square dx, which is, so 4x to the power 4 minus 4x square minus plus 1 exponential minus x square dx, right? So now we can just separate these three parts, 4x to the power 4 exponential minus x square dx minus infinity to plus infinity 4x square exponential minus x square dx, then plus minus infinity to plus infinity just this part x square minus x square dx, right? So this, let's call this first part, second part and third part. So for first part, so for integration is 4 is constant minus infinity to infinity x to the power 4 exponential minus x square dx, right? So if you just use this integration that is given, this part x to the power 2n exponential minus x square dx. So for x to the power 4 case, if you just compare this term, n will be equal to 2, right? So that means for x to the power 4 case, it will be 1 3 5 dot 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 2 times 2 minus 1, 4 minus 1, that means 3. So it will be like 1 to 3. So it will go from 1 and 3 only, divided by 2 to the power n. So n is 2, then root pi, right? That means 3 divided by 2 square means 4 root pi, right? So this part you got it, right? Sikha?
Yes, sir.
Okay. So for x to the power 4 case, the integration will be 3 by 4 root pi. So first part 4 times 3 by 4 root pi, 4 will cancel, it will be just 3 root pi. So this is first part. Then second part will be just 4 will get common, then x to the power square exponential minus x square dx. So here if you just compare with this term, with this, with x to the power square term, right? So here n will be equal to 1. So if you compare with this term, so for x to the power square case, it will be 1, n equal to 1. N equal to 1 means here if you put n equal to 1, 2 minus 1, which is 1. So just 1. So 1 divided by 2 to the power n equal to 1, 2 to the power 1 root pi. So just half of root pi, right?
So, sir, how
Yeah.
1 by 2?
Okay, let me just clearly write it. So basically it is given x to the power 2n exponential minus x square dx equal to 1, 3, 5 dot 2n minus 1 divided by 2 to the power n root pi, right? So here we are just comparing with this term. So here exponential minus x square is identical, so x to the power 2n and x square we have to compare. So if we compare x to the power 2n with x square, so here n will be equal to 1, right?
Yes, sir.
So for n equal to 1, you have to evaluate this term. So if you just put here this here n equal to 1, that means 2 times 1 minus 1, that is 1, right? So this is a series. So 1, 3, 5 dot 2n minus 1 means this is a series. In general for any n, this is true, but for n equal to 1 case, so 2n minus 1 is the last number. That means for n equal to 1 case, the last number will be just 1, right? 2 times 1 minus 1, that means 1. So there is only one number which will be left, right? 1 divided by 2 to the power n equal to 1 means 2, it is root pi. 2 to the power n, 2 to the power 1 means 2, right? So that's why half root pi. Now it is it clear?
Yes, sir, clear.
Okay. Okay, so for second part it will be just second part, it will be just 4 times half root pi, which will be just 2 root pi. Okay, now third part. So third part is this part, just minus infinity to infinity exponential minus x square dx. Now if you compare with this equation with this part, so exponential, just only exponential term is left. So here if you put n equal to 0, here if you put n equal to 0, so x to the power 0 will be equal to 1, so then we will get 1 here, right? So in general here for third part it will be just n equal to 0. So n equal to 0 means overall it will be 0. Overall it will be root pi. Okay, so just for only one term is given, so it will be just root pi. So for okay, so now in general, if you just put here, or if you just combine three parts, so basically n square times first part is actually 3 root pi, second part is minus 2 root pi, third part is root pi is equal to 1. So n square times 3 minus 2, 1 plus 2 root pi, right? So n square is 1 upon 2 root pi. So n will be equal to just root over of 1 upon 2 root pi, 1 upon 2 root pi to the power half. Okay, so basically the value of n or normalization constant is 1 upon 2 root pi to the power half. Okay, clear, Sika?
Okay, sir. Thank you.
Okay, so you have to just actually the main formula is for any wave function the normalization condition is this. Okay, let me just clearly write it. The given range, let's say minus a2 plus a, then mod of psi square dx, which would be equal to 1. So this is for in general any wave function. This is normalization condition. Now mod of psi square means in general it is psi times psi star. Psi star is the conjugate part of psi. Now for any real psi, any real wave function, psi is equal to psi star. Okay, that means psi times psi star for any real wave function, it will be just psi square. Okay, so for any real wave function the normalization condition will be, let's say, minus a2 plus a psi square dx. So this is the normalization condition. Now for then you have to just use this given integration formula, this formula for different n value, then you can just compute it. Okay, so for n equal to 0 case, so there for this part there will be no, just 1 will remain, and here if you just put n equal to 0, 2 to the power 0 equal to 1, so just root pi is left. So for just this is general integration exponential minus x square dx minus infinity to infinity, which will be equal to just root pi. Okay, and if you can remember this, you can just remember this is very important. Like for minus infinity to plus infinity, exponential minus, let's say, ax square dx, let's say a is greater than 0 and any constant. Okay, so this integration is called the Gaussian integration, and in general it is, the value of this integration is root over of pi by a. Okay, so this is the value of the integration in general. You can just remember it. Okay, now let's discuss the second part of the second question, so which is the kinetics part. So consider the reaction A plus B to C, and we have to find out the unit of equilibrium constant for this reaction. Okay, equilibrium constant means K equilibrium. So we have to find out the unit of K equilibrium for this reaction. Okay, so anyone can guess how should we proceed?
So actually there is a doubt in dimensionless and liter mole inverse.
Yeah, so basically the formula is, so we know the equilibrium constant for any this type of reaction is, let's say this is forward rate constant and let's say this is backward rate constant. Okay, so basically it is k1 by k minus 1, which will be equal to the concentration of product. In general I am writing this, so concentration of product divided by concentration of reactant. If any chemical reaction is in equilibrium, that means the equilibrium constant for those chemical reaction, which will be equal to k equilibrium, is equal to the forward rate constant divided by backward rate constant, which is eventually equal to the concentration of product divided by concentration of reactant. Now for this reaction, product is C and reactant is actually 2 reactant. That means concentration of A times concentration of B, right? Now for any what is the unit of concentration? Mole per liter in general. So concentration of C will be mole liter inverse, concentration of A will be mole liter inverse, concentration of B will be mole liter inverse, right? So 1 mole liter inverse will cancel and 1 will remain in the denominator, mole liter inverse, right? So 1 upon mole liter inverse means what? Liter mole inverse, right? So basically that's the answer. So option B is the correct answer. So here option A are, I am writing down the option mole liter inverse. Option B is liter mole inverse. Option C is mole square liter minus 2. Option D is dimensionless. Okay, so you are saying
So I'm saying that concentration for solids is taken as unity, na?
no, that is not true. That is
But here it is not given that it is solid, liquid or gas. That's why dimensionless.
no, that is not true, because here it is the concentration of product. If it is said that the activity of solid, so basically we are saying that the activity of solid is taken as 1. Activity of any solid or any pure compound is generally taken as 1. Okay, so that is another case. But here the equilibrium constant is basically the ratio of product concentration and the reactant concentration. Now concentration of product you can define by any units. Let's say it is in mole liter inverse unit, mole per liter. So here the product is only one product C and the reactants are 2, so A and B. That's why in the numerator part it will be 1 mole per liter, and in the denominator part there will be 2 mole per liter. That's why 1 mole per liter is remain in the denominator and the unit will be liter mole inverse. Okay.
Okay, sir. Okay, sir.
So do anyone know what is the correct answer? So option B should be the correct answer. previous year questions from conductance part. Okay, so basically first let's discuss some okay, so strong electrolyte and weak electrolyte. Okay, so strong electrolyte means the electrolyte means any salt, or basically so electrolyte means any substance. When you dissolve this substance in aqueous system, so it will basically dissociate into cations and anions. Okay, so electrolyte means any substance which after dissolving into aqueous system it will break into cations and anions. So strong electrolyte means when the dissociation, or after dissolving the electrolyte is 100% dissociating, means it will generate 100% cations and anions. Or weak electrolyte means the degree of dissociation is not 100%, or basically it is not 1. That means not all the electrolyte will dissociate into cations and anions. Some of the electrolyte will remain intact. So that is why we call it weak electrolyte. So let's first see an example. So strong electrolyte, basically NaCl. So sodium chloride is, if you dissolve into water, then you will get Na plus and Cl minus. So it will 100% dissolve. It will dissociate 100%. Means if you 100%. So if you just take 1 mole of NaCl, then after dissolving into water, you will get 1 mole of Na plus and 1 mole of Cl minus. Okay, so here the degree of dissociation. So degree of dissociation means how much it is dissociating, what is the extent of dissociation. So degree of dissociation is 100%. It is often denoted by alpha, so alpha equal to 1 for strong electrolyte case. Now for weak electrolyte, there is acetic acid CH3COOH, right? So if you dissolve into water, so acetic acid will not dissociate 100%. Okay, so some of the acetic acid will remain intact. So you will get acetate ion CH3COO minus and H plus. But here if you start with 1 mole of acetic acid, you will not get 1 mole of acetate ion and 1 mole of H plus like in case of NaCl you will get. So let's say it is in the degree of dissociation of acetic acid is alpha, so you will get like this. Okay, so alpha amount will dissociate, alpha amount of acetic acid will get dissociated, so you will get alpha amount of acetate ion and alpha amount of H plus. Okay, and 1 minus alpha will remain intact. So this is called the degree of dissociation of weak electrolyte case. Now if you just how can we actually increase the extent of dissociation or the degree of dissociation of weak electrolyte or strong electrolyte? So if you dilute the system, it's first in a beaker, there is a certain amount of water or certain amount of salt concentration, let's say NaCl you take, and there is some concentration of NaCl, okay, initial concentration. And if you dissolve this solution, if you dilute this solution, that means if you decrease the concentration of NaCl in this system, that means if you add more water in this system, dilution means if you add more water in this system, then the degree of dissociation or the number of ions you will get, cations and anions, will get increased. Okay, in case of weak electrolyte case also, if you dilute the system, then number of cations and anions will get increased. That means the degree of dissociation alpha will get increased. Okay. That means by dilution alpha will be increased. Why this is so? Because if you dilute the system, so basically if you dilute the system, so at first, before dilution, let's say initial Na plus Cl minus, right? But in concentrated solution, these cations and anions, there will be an electrostatic interaction or attraction between these ions, right? Na plus and Cl minus ions. So it is difficult to get separate cations and anions for high concentrated system. So that's why if you now dilute the system, so after dilution, so in between cation Na plus and Cl minus, now there will be water, right? Because you are adding water in the system, so the electrostatic attraction between these cations and anions will get decreased. So that's why you will get more number of distinguishable or separate cations and anions. So that's why the degree of dissociation will get increased after dilution. So there is a law here, so which we call the Ostwald dilution law. So which is the basically the relationship between the molar conductance. Now okay, I'll just briefly conductance with concentration. Now if the number of ions, cations or anions gets increased in the system, then the conductance will increase, right? Conductance means the ability or ease of flow of current or ease of flow of ions through the system. So basically conductance means actually ease of flow of ions in the system. If we apply voltage, so cations and anions will go towards the cathode and anode, so that the ease of flow of ions in the system is called the conductance. So you can just derive the useful expression for the conductance, like from this formula, R equal to rho times L by A, right? So this is the formula we actually know from the physics. So R is basically resistance, rho is the specific resistance or resistivity, L is the length between the two electrodes, right? So like if in the beaker, if this is these two electrodes, so length between these two electrodes is called L, and A is the area of this cell, like between the two electrons, what is the area? This is area. Okay. Now conductance means, so resistance means it will prevent to flow the ions after applying the voltage. Like, so conductance is the opposite of resistance. Conductance is the ease of flow of the ions in the system. So conductance is basically, let's call it lambda. Lambda is the inverse of resistance, 1 over R. Okay. So lambda will be 1 upon rho times A by L. Okay. So lambda is the conductance, which is the inverse of resistance. So 1 upon rho is we call kappa times A over L. So this is the main relationship. Lambda is conductance, kappa is the specific conductance or conductivity, specific conductance or conductivity, which is opposite of 1 upon rho, like which is the specific resistance or resistivity, and A by L. Now L by A, there is a name for it, which is the cell constant. Cell constant is L by A. That means the ratio between the length between these two electrode and the area of this space. Okay, area of this space. So ratio of length by area is called the cell constant. So basically the conductance lambda is kappa times cell constant. Now you can also define the unit here. So unit is very important in this case. So let's first, okay, R equal to rho times L by A. So you can define units from this expression. Let's do it in the centimeter. So the unit of resistance is ohm, we know that. Rho times L is length, which is centimeter, and A is area, which is centimeter square. So ohm equal to rho times 1 upon centimeter. Okay, so unit of rho, this is unit of rho will be equal to ohm centimeter, or in SI unit it will be ohm meter in centimeter. Unit of rho, that means resistance, resistivity, specific resistance or resistivity is ohm centimeter. Okay, now for this is for resistance case. Now for conductance case, so basically kappa is specific conductance, or conductivity, right? So unit of kappa will be 1 upon rho, right? 1 upon rho means 1 upon ohm centimeter or ohm meter. That means ohm inverse centimeter inverse, and ohm inverse, we know there is a name for it, Siemens or Siemens, whatever you want to call it. Okay, so basically kappa, unit of kappa, specific conductance or conductivity, is ohm inverse centimeter inverse. Okay, and what is the unit of conductance? Lambda, capital lambda. Lambda will be equal to 1 upon R, 1 upon resistance, right? So we know our unit of R is ohm, so 1 upon ohm, which is ohm inverse. So basically unit of conductance is ohm inverse, and unit of conductivity is ohm inverse centimeter inverse or ohm inverse meter inverse. Okay, now there is an important concept. So this is basically means any conductance, in general conductance lambda, but for molar conductance, molar conductance means if in the cell, let's say these are the two electrodes, and in the cell the concentration of the solution is actually 1 molar, then the conductance of electrolyte or of ions is called the molar conductance. So basically the expression for molar conductance, let's call it lambda m, which will be equal to kappa divided by C. Okay, I will explain the terms here. So basically lambda m is molar conductance kappa we know conductivity or specific conductance. C is the concentration of electrolyte in mole per liter unit. Okay, mole per liter unit. Now let's say, so kappa, let's say unit is, kappa means specific conductance, unit is let's say ohm inverse, centimeter inverse. So in any numerical question, let's say the value of kappa and concentration is given to you, and in the question you have asked to find the value of lambda m. Now let's, the kappa unit of kappa is ohm inverse, centimeter inverse. In the question the value is given in this unit, and the concentration is given, let's say mole per liter unit. That means mole liter inverse unit, it is given in the question. Okay, if you just divide the value of kappa and value of C which is given in the question to find out lambda m, it will be wrong. Why? Because the kappa is in centimeter inverse unit and C is in mole liter inverse unit. So you have to convert liter to centimeter first, which is the basically kappa ohm inverse, centimeter inverse, and C mole liter inverse. So basically 1 liter equal to 1 decimeter cube, which is 1 centimeter cube. Okay, 1 liter equal to 1000 cc, 1000 centimeter cube. So basically liter inverse, so it will be 10 to the power minus 3 centimeter to the power minus 3. Okay, so
Sir, please repeat this step.
Yeah. So basically the kappa is given in centimeter inverse unit, let's say, and concentration is given, let's say, in mole per liter unit. Okay, so to make the unit actually consistent, so you have to first convert liter to centimeter. So we know that the 1 liter equal to 1000 cc, right? We know that. So cc means centimeter cube, so 1 liter equal to 1000 centimeter cube. Okay, now let's clearly, so it is ohm inverse, centimeter inverse, then C mole as it is, then you have to just convert liter inverse to centimeter in centimeter unit. So 1 liter equal to 1000 cc, that means 10 to the power 3 centimeter cube. So 1 liter inverse, which will be what, 10 to the power minus 3 centimeter to the power minus cube, right? So liter inverse will be 10 to the power minus 3 centimeter minus 2. Now this step is clear?
Yes, sir.
Okay, so basically 10 to the power minus 3 is in the denominator now, so if you just you can just take it in the numerator. So kappa in ohm inverse, centimeter inverse, times 10 to the power 3, it will be 10 to the power 3 if you just take the 10 to the power minus 3 from denominator to numerator, right? Then C in unit of mole, centimeter minus T. Now it is consistent. Okay, so basically it will be lambda m. You have to be careful while solving the numerical questions, so you have to be careful to the units of kappa and C. Okay, now let's say kappa is in ohm inverse meter inverse unit. Okay, so then let's say C is in mole per liter in unit. Then you have to convert liter to meter unit. Okay, so basically 1 liter inverse equal to 10 to the power minus 3, sorry, 1 liter equal to 10 to the power 3 semi cube, we know this. Then you have to convert centimeter to meter, so we know the 1 centimeter equal to 10 to the power minus 2 meter, right? So it is 10 to the power 3 times 10 to the power minus 6 meter cube. So 10 to the power minus 3 meter cube. So 1 liter is equal to 10 to the power minus 3 meter cube. Okay.
So I didn't get it.
Okay. So the 1 liter is 10 to the power 3 semi cube, right? And we know that 1 centimeter is equal to 10 to the power minus 2 meter. We know that. So now what will happen? So then just replace this, replace this here. So 1 liter is 10 to the power 3 times 1 centimeter equal to 10 to the power minus 2. So 10 to the power minus 2 meter whole cube, right? If you just replace this, so 10 to the power 3 times, so 10 to the power minus 2 cube, what will be 10 to the power minus 6 meter cube. So is it clear now?
Okay, sir, one time repeat.
Okay, so basically this is centimeter cube, right? Centimeter cube, so that means centimeter to the power cube, 1 centimeter cube. So you are replacing 1 centimeter by meter. So 1 centimeter is 10 to the power minus 2 meter, right? So you are replacing this only. So 10 to, now what will happen? So 10 to the power minus 2 cube times meter cube. That's why 10 to the power minus 6 times meter cube.
Okay, sir.
Okay, na?
Yes, sir.
Okay, so okay, let me just do it again clearly. The 1 liter is 1000 centimeter cube. That means 10 to the power cube centimeter cube. Okay. So basically this is means this, right? Centimeter cube means 1 centimeter cube, and 1 centimeter equal to, we know, 10 to the power minus 2 meter. So this, just replace this now here. So 10 to the power 3, it was already there. Then you are replacing 1 centimeter by 10 to the power minus 2 meter. 10 to the power minus 2 meter cube. So 10 to the power 3, it was already there. So 10 to the power 2 minus 2 meter whole cube. So 10 to the power minus 2 cube times meter cube. So 10 to the power 3, 10 to the power minus 2 cube means 10 to the power minus 6 times meter cube. So 10 to the power minus 3 meter cube. Now, is it clear?
Yes, sir.
So basically the main funda is, so you have to just careful the units of kappa and C. If kappa is in meter, then you have to, and concentration is mole per liter, then you have to convert liter to meter. And if kappa is centimeter inverse and concentration is mole per liter, then you have to convert liter to centimeter. Okay, so you have to just remember this. Okay, let's okay, now what I was talking about. Yep. So basically after dilution, the degree of dissociation or extent of dissociation alpha will increase. So there is a law here which is Kohlrausch's law. We know that. Don't know the spelling. So basically Kohlrausch's law said that, like, for strong electrolyte case, in y-axis you plot molar conductance, in x-axis you plot root over of concentration of electrolyte. For strong electrolyte there is a straight line. Okay. So basically if you decrease concentration, like if you go in this direction, if you decrease concentration, that means you are increasing dilution. Decreasing concentration means you are increasing dilution. So that means, so in this direction, if you increase dilution, the molar conductance of strong electrolyte will increase, right? This is increasing in this direction. And for weak electrolyte case, so this is for strong electrolyte. And for weak electrolyte case, the plot will look like this. Not straight line, but in a curved line. Okay. This is for weak electrolyte. In this case also, if you just increase dilution in this direction, the molar conductance of weak electrolyte is also increasing. Okay. But the curve is different. Nature of increase nature at which it is increasing is different. So electrolyte. Okay, now if you just extrapolate this, extrapolate means if you just straight line, so you can extrapolate this. If you just extrapolate this, the molar conductance at C equal to 0, concentration equal to 0 means that is the solution is infinitely diluted. Okay, that we call it infinite dilution. That is not possible in physical sense because you cannot infinitely dilute any solution, but if you dilute enough, then we call it infinite dilution. So infinite dilution basically means any solution where concentration C is equal to 0. So for strong electrolyte case, because of the nature of the straight line, you can extrapolate this, and the axis at which the C equal to 0 case, the conductance value, molar conductance value, we call it lambda m0. So we call it the molar conductance at infinite dilution. Lambda m0, okay, for strong electrolyte case. Okay, so now the Kohlrausch's law said that, or Oswald dilution law, there is an Oswald dilution law said that for lambda m0, so lambda m is equal to some constant which is lambda m0 minus b root c. Okay, I am rewriting this, equal to lambda m0 minus b. This is Oswald dilution law. Lambda m is molar conductance at any concentration. Lambda m0 is molar conductance at infinite dilution. C is concentration, B is any constant. Okay, this is the Oswald dilution law. That means if you decrease the concentration means increase the dilution, then because of this negative sign, the molar conductance will increase. Okay, so now there is a question. I will discuss one question, then in the next class I will discuss other questions. So if the concentration C is increased to 4 times its original value. Now the change in molar conductivity for strong electrolyte. This is for strong electrolyte, remember this, because of the nature of the straight line. Weak electrolyte case, there is no exact formula for this. Strong electrolyte, this B is called the Kohlraasch constant. So this is any constant, is called the Kohlraasch constant. Okay, now the question is, if the concentration of any electrolyte solution is increased to 4 times to its original value, then the change in molar conductivity or molar conductance is, okay, so let's use this formula, lambda m equal to lambda m0 minus b times root c. This is our main formula. So this is, let's say, this is our initial case, original case. Now we are increasing the concentration by 4 times, let's say, which is lambda m, let's say this is 1, this is 2. So lambda m0 will be fixed, will have a fixed value, okay. So it will not change with concentration because it is concentration equal to 0 case, so it will have a fixed value. So second case also, lambda m0, Kohlraasch constant will be fixed, will be same, times 4c. So we are increasing concentration up to 4 times, okay. So lambda m2 is equal to lambda m0 minus 2b root c. Okay, now the change in molar conductance means lambda m2 minus initial lambda m1, this is the change, right? So just let's say equation 1, equation 2, so 2 minus 1, lambda m0 minus 2b root c, this is lambda equal to 2, minus lambda m1 means lambda m0 plus b root c. Okay, so lambda m0 will get cancelled out, so it will be just, so basically it will be minus b root c, right? The change in the modulus of change basically is modulus. It can be negative, it can be positive. So if you take mod, so mod of lambda by root c means just b root c. Okay, so basically there are 4 options. Option A is 0, option B is b root c, option C is 2b root c, option D is 4b root c. So clearly the change in molar conductance, if you increase the concentration up to 4 times, is b root c. So option B is the correct answer. So the question is not important. So actually the main important thing is this relationship for strong electrolyte case, lambda m equal to lambda m0 minus b times root c. Now here you just replace c with 4 times c and subtract with the initial lambda m, then you can get the value of the change of molar conductance. Then if you just take the modulus of this, then you will get the how the change is varying with concentration, which is, for this question, it is b root c. Okay, now is it clear up to now?
Yes, sir. Thank you so much.
Yeah. So in the next class, I will discuss more previous year questions from conductance and electrochemistry. Then probably I think next class is the last class. Or before gate exam, if you face any doubts, so you can just send me a mail. Okay, so any doubts from any of you, or is it fine? All clear? Actually record, though I sent all the recordings to the NPTEL coordinators, but I think they haven't uploaded on any recordings yet. So if you need, I can just send you the link of my recording, YouTube link. So
Sir, even phase 1 recordings are also not available. Your classes are available, but Tuesday, Wednesday, they're not available.
Yeah. I don't know why they haven't uploaded any recordings. So all the recordings, we actually sent all the recordings to the coordinator. So if you need, I can just send you the recording link. Okay, just email me. Just